When you're flying a holding pattern, your primary objective is to stay within the protected airspace. In some cases, it's also important to be able to leave the holding fix at a specified time. Now, in a no-wind condition, both of these are pretty darn easy. For example, the turns at each end of a holding pattern are 180 degrees. And in a holding pattern, as in the rest of your IFR flying, you make standard rate turns, which, as you remember, are 3 degrees of turn per second. So, at a standard rate, each turn of 180 degrees takes exactly 1 minute. And when you're holding below 14,000 feet, the legs should be exactly 1 minute long. So, in a no-wind condition, a complete pattern should take exactly 4 minutes. Knowing all this gives you the information you need to be able to leave the holding fix from here at a specific time. For example, if you're supposed to leave the holding fix at 1820 and the time now as you cross this holding fix is 1817, you've got 3 minutes to go. You would subtract 1817 from 1820 and that gives you 3 minutes. So how do you do that? Well, you'd shorten the outbound and inbound legs to 30 seconds each, keeping your 180-degree turns at 1 minute, and voila, you'd be back over the fix in 3 minutes, which is exactly enough time to boil an egg. So you'd probably agree that in a no-wind situation, holding is pretty simple. But how about when there is a wind? Well, let's take a look. We'll set up a holding pattern on the 090 radial of the Liberal Kansas VOR and put the wind from the west, making it a direct headwind on the inbound leg. In this case, if you fly exactly 1 minute on your outbound leg, your inbound leg will take longer than 1 minute on its return to the fix. And why is that? Well, you know. You have a tailwind on the outbound leg, which increases your ground speed, and a headwind on the inbound leg, which decreases your ground speed. So here's the key. It's the inbound leg that you want to be as close to 1 minute as possible. Now, in order to do that, you shorten or lengthen the time of the outbound leg as needed. It's kind of like a recipe. Now, if you don't have good wind information ahead of time, the first trip around the holding pattern, you will need to time the outbound leg for 1 minute. Make sure you get your timer set as you complete this turn and get 1 minute before you start your inbound turn. But as soon as you finish your turn to the inbound leg, you'll start that timer / clock again because you want to know how long it takes you to get to the holding fix on the inbound leg. That will tell you how much, if any, you'll need to adjust the timing on the outbound leg. So let's say that the inbound leg takes you 1 minute and 20 seconds, a little longer than a minute, right? Well, you want to try to reduce your outbound leg by, let's say, 15 seconds, making it now only 45 seconds long, and see what you get on the next inbound leg. Now, if you've done a really good job of correcting your outbound leg timing, you'll track that radial back to the holding fix in exactly 1 minute. And you should be able to nail the timing within, I'd say, 3 times around the pattern. But what if the wind is a crosswind instead? Let's suppose the wind is coming from the north now. Well, if you fail to correct for the crosswind, here's what would happen. During your turn to the outbound leg, the wind would push you south, shortening the radius of the turn. You'd actually end up closer to the inbound leg than you would if there were no crosswind. See the difference in the distance here? Then, if you still don't correct for that wind from the north, when you flew your outbound leg, it would push you even further south into the inbound leg. See the difference in distance here as opposed to here. And as you made your standard rate turn to the inbound leg, the wind would still be pushing you south, and this time it would increase the radius of your turn. You could end up overshooting this radial by a wide margin for your inbound leg, and you'd be down here outside of your protected airspace. This is not good for the air traffic controller, for other traffic, or for your own continued good health. So let's take a look at how you correct for a crosswind in a holding pattern. First, you'll need to set up a wind correction angle on both the inbound and the outbound legs. Let's assume that on the inbound leg, 5 degrees of wind correction holds you on your radial. On the outbound leg, you should double the wind correction angle that you use on this inbound leg. And you do this to compensate for the fact that you are not making any crosswind correction during your turns. Since in this case, the wind correction angle on the inbound leg, as we said, was 5 degrees of correction, you should use a 10-degree correction on the outbound leg. You'll be flying away from the inbound leg at an angle, and when you make your standard rate turn to come back and intercept the inbound leg, you should roll out exactly on the 090 radial. Now this creates a strange looking keyhole-shaped pattern. But the important thing is that you'll finish your turn to the inbound leg just as you intercept that 090 radial. Once again, if you don't know where the wind is from, you'll have to use your first trip around the holding pattern to figure it out. But if you know the wind ahead of time, you can establish the approximate corrections you'll need from the very beginning. Now, one problem pilots have is determining when to start timing the outbound leg. Well, the most accurate and appropriate place for you to start timing the outbound leg is abeam the holding fix. If you're holding at a VOR, you know that you're abeam the holding fix when the to from flag reverses. And when you're holding at an NDB, you start the clock when the magnetic bearing is 90 degrees to the inbound leg. But if you're holding at the intersection of two radials, or a radial and an NDB bearing, it's a little harder to figure out when you're abeam the fix. In that case, your best choice is to start your timing when the wings are level after the turn outbound. By the way, if ATC puts you in a holding pattern, remember that you are still burning fuel and you'll need to recalculate your fuel reserves based on the EFC, or expect further clearance time, that ATC gave you. Now, you can't stop using fuel while you're holding, but you can certainly reduce your power and save fuel while you're basically going nowhere. For example, the Skyhawk 172R uses over 30% less fuel if you reduce power from 75% to 50%, and that's fuel you might find very useful later on. Well, now you know what your holding pattern will look like with or without wind. And so what if your pattern doesn't exactly look like a day at the racetrack? So long as you stay within the protected area, you'll be secure, safe, and happy. And I call that a flying trifecta.